Today we're going to learn some counting techniques. So let's start from rule of product, rule of sum, and permutations. These called common counting techniques. Okay, we shall learn some common counting techniques in the first part of Unit 1, and in the second part of Unit 1, we'll learn some other counting techniques. So the reason why we need to learn the common counting techniques is to calculate the probability of a given event. Remember that the theoretical probability of this event is denoted as the number of sample points in this event divided by the number of sample points in the sample space, right? So in order to find the number of sample points in this event and the number of sample points in the sample space, we can use some common counting techniques, right? So the reason we need to learn these is to calculate the probability, okay? So I'll show you how to do this later in our lessons, okay? So first of all, let's start from factorials. If you have learned this, you can treat it as a review. So first, I'll read the definition for you. Factorials. The symbol n exclamation sign read as n factorial represents the product of all integers from n to 1. In other words, n factorial is defined as n multiplied with n minus 1, n minus 2, n minus 3, all the way until 3 to 1. All right? And also, by definition, 0 factorial is defined as 1. Okay? So, any questions here? No? Okay, if you don't have any questions, let's do some quick practice. So what is 0 factorial? By definition, 0 factorial is 1, right? Okay, now let's see what is 1 factorial. 1 factorial is also 1, right? So what is 2 factorial? Okay, so according to the definition, 2 factorial is 2 times 1, right? This equals 2. So how about 5 factorial? 5 factorial is 5 by 4 by 3 by 2 by 1, right? And this is 20 times 6, which is 120. So understand? Any questions regarding factorial? No? Okay. Next, let's have a look at the first common counting techniques we're going to learn. This is a very basic. This is all the fundamentals for the following counting techniques. Okay, this is called rule of product. If there are A ways of doing something, and for each way in the A ways, there are B ways of doing another thing, then there are A times B ways of performing both actions. Understand? Okay, I'll explain it in Chinese again. 好，第一个我们用来数数的常用方法叫做乘法原理，这个是之后我们要学习之后的那个数数方法的一个最基本的方法啊。他说的什么意思呢？如果某件事情需要经过 k 个步骤才能完成，如果做第一步有 m1 种方式，做第二步有 m2 种方式，做第 k 步有 mk 种方式，那么完成这件事情共有多少种方式呢？我们要把这种不同步骤的不同种方式都乘起来。Okay. Now I'll draw you a diagram to illustrate this process. So, okay, suppose if you want to finish a task there are k steps, right? So note that the key is k steps. Okay, so in the first step, if you have m1 different ways, okay, m1 different ways to finish the first step, and m2 different ways to finish the second step, and m3 different ways to finish the third step, and mk different ways to finish the last step. So what is the total number of ways can you complete this task? According to the rule of product, we need to multiply these numbers together. So this is the total number of ways you can complete the whole task. Understand? Okay, let me show you an example. Suppose there are 3 cities, A, B, and C. And we know that from A to B, there are 3 tourism routes. And from B to C, there are 2 different tourism routes. So how many tourism routes from A to C in total? That means how many methods are there to get from A to C? Okay, according to the product, a rule product, to finish the whole task, there are 2 steps, right? First step is from A to B. Next step is from B to C. So there are 2 steps. The first step, we have 3 different ways. Second step, we have 2 different ways to finish. So according to rule of product, we need to times these 2 numbers up. And this gives us total number of ways we can complete this task, right? Which is a 6. So there are 6 different ways in total we can get from A to C, right? Any questions? No? Okay. Let me show you another example. Consider there are 3 tosses of a coin. How many total outcomes this experiment has? So we can consider it as a process that contains 3 steps, right? First step is to toss it once. So first step is actually the first toss, right? And second step is the second toss. And the third step is, of course, the third toss, right? So how many different ways we can finish the first toss? We can have either a H, that means head, or a tail, right? So there are 2 different ways to finish the first step, and another 2 different ways to finish the second step, and another 2 different outcomes in the third step. So how many different ways we can finish the task? There are 2 by 2 by 2, which is 8 different ways we can finish the whole task, right? So there are 8 total outcomes this experiment has. You understand? We can solve this question by using the rule of product. Okay, any questions? No? Okay, let's see another quiz. A National Football League team will play 16 games during a regular season. Each game can result in one of 3 outcomes: a win, a loss, or a tie. How many total outcomes are possible? Okay, for the specific team, to finish the whole task, there are 16 steps, right? So if there are steps, we can consider using the rule of product. So for each step, how many different ways can we finish each step? We can have a win, a loss, or a tie, right? So that means the total number of outcomes, which means the total number of ways we can finish the whole task, is first step is 3, second step 3 ways, third step 3 ways. You can multiply all these numbers together, right? And last step, which is 16th step, we still have 3 different ways, right? So there are 16 6 that are multiplied together, which means total number of outcomes is 6 to the 16th power, right? Okay, any questions? No? Okay. All right, I'll leave this quiz for you to solve. Okay, I'll give you 5 minutes. A college planning committee consists of 3 freshmen, 4 sophomores, 5 juniors, and 2 seniors. A subcommittee of 4 consisting of 1 person from each class is to be chosen. How many different subcommittees are possible? All right, have you finished? Okay, are there any steps to finish the whole task? Of course there are, right? Because we need to choose some persons from 4 different kinds of persons. First step is to draw a person from freshman. Second step is to draw a person from sophomores. The third step is to draw a person from juniors. And fourth step is to draw a person from the 2 seniors, right? So there are 4 steps to finish the whole task. And the first step, how many different ways can you finish the first step? You can choose one from 3 different persons, right? So in the first step, we have 3 different ways to finish that. How about the second one? Second one, we can have 4 different ways, right? And for the next step, we have 5 different ways. And for the last step, we have 2 different ways. So this is the total number of different ways we can finish the whole task, which is 120. Okay, any questions? No? Okay, you can also check the solution to this problem is the next page. Okay, another example is how many different 7-place license plates are possible if the first 3 places are to be occupied by letters and the final 4 by numbers. Okay, again, I'll leave you 3 minutes to think about this question. Okay, finish. So are there any steps to finish the whole task? Of course there are, right? There are 7 steps. In the first step, we need to choose some letters. So for the first step, we can choose 1 letter from the 26 letters, right? Because in the alphabet there are 26 letters. So for the first step, we choose one from 26 letters. That means we have 26 different ways to complete the first task. How about the second one? Second one is very similar to the first one. We also have 26 ways to complete the second task. The third task is to fill a letter from the 26 letters. So again, we have 26 different ways to complete the third step. So how about the fourth step? The fourth step, we choose one digit out of 10 digits, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 different digits. So we have 10 different ways to complete the fourth task. And for the 5, 6, or 7 task, it's the same with the fourth task. We also have 10 different ways to complete the remaining tasks, right? So this is the total number of ways we can complete the whole task. That means we have this number of ways, this number of different number plate, right? Okay, any questions? No? Okay, let's see. Next example. A small community consists of 10 women, each of whom has 3 children. If one woman and one of her children are to be chosen as mother and child of the year, how many different choices are possible? Okay, this is a simple question. I'll leave you 2 minutes to think about this. Okay, any questions? So how many steps to finish the whole task? There are 2 steps, right? In the first step, we have 10 choices. And after we finish the first step, for the second step, we have 3 different ways to finish, right? So for the whole task, we have 30 different ways to complete the whole task. Any questions? No? Okay, let's see the next one. Okay, next concept is called rule of thumb. If we have A ways of doing something and B ways of doing another thing, and we cannot do both at the same time, then there are A plus B ways to choose one of the actions. Okay, again, I'll explain this in Chinese. 下一个 counting technique 我们学的是加法原理。什么叫加法原理呢？如果某件事情可由 K 类不同的途径之一去完成，在第一类途径中有 M1 种完成方法，在第二类途径中有 M2 种完成方法，在第 K 类途径中有 MK 种完成方法。那么完成这件事情一共有 M1 加 M2 加一直加到 MK 这么多种方法，能明白吗？ Okay, again, I'll draw you a diagram to help you illustrate. Okay, suppose we want to finish this task, right? And there are k different routes we can finish the whole task. Okay, suppose we can do the task via different route. So there are k different routes we can finish the task. In the first route, we have m1 different ways. In the second route, we have m2 different ways. And in the kth route, we have mk different ways. So in total, how many different ways we can finish this task? Of course, we can just add these numbers up, right? So there are m1 plus m2 plus m3 and plus mk. This is the total number of ways we can complete the task. Okay, let's see a concrete example. A woman has decided to shop at one store today, either in the north part of town or the south part of town. If she visits the north part of town, she will shop at either a mall, a furniture store, or jewelry store, 3 ways. If she visits the south part of town, then she will shop at either a clothing store or a shoe store. The question is, how many possible shops the woman could end up shopping today? Okay, so how do we approach this problem? The task is shopping, right? There are two routes you can finish this task. One of the route is to shop north, in which there are 3 ways, right? Or you can also shop south. If you shop south, there are 2 ways, right? So to complete the whole task, there are 3 plus 2 number of ways, which means there are 5 different ways to finish shopping, right? According to the rule of thumb. Okay, so now can you see the difference? One to use rule of product and one to use rule of thumb. So let's make a summary. If there are k steps, if to complete a task, there are steps, you need to consider use the rule of product, right? If to complete a task, there are k different routes, then you need to consider use the rule of thumb. Okay. All right, let's see another example. Kelvin wants to go to Milwaukee. He can choose from 3 bus services or 2 train services to head from home to downtown Chicago. From there, he can choose from 2 bus services or 3 train services to head to Milwaukee. How many ways are there for Kelvin to get to Milwaukee? Okay, I'll give you 5 minutes to think about this question. Okay, have you finished? Okay, we can draw a diagram to illustrate this problem. So first of all, there are two steps to finish this task, right? First step is to go from home to Chicago, and second step is to go from Chicago to Milwaukee. So in the first step, how many ways we can finish the first step? We can take 3 bus services. We can choose one from 3 bus services or choose one from 2 train services, right? So in the first step, we have 5 different ways to finish, right? So similarly, in the second step, we can choose one bus services from the 2 and choose 1 train services from the 3. So in the second step, we have another 5 different ways to finish, right? So according to rule of product, there are 5 by 5, which is 25 different ways to go from home to Milwaukee. Do you understand? Any questions? No? Okay, let's continue. Next, we need to discuss permutations. Okay, this is a new concept, relatively new concept. So first I'll explain this in English and then in Chinese. First, let's have a look at the definitions. Permutations gives the total number of selections of X elements from N different elements in such a way that the order of the selection is important. The notation used to denote the permutations is Pnx, or we can also use Pnx as this, or Pnx as a form of a function, which is read as the number of permutations of selecting X elements from N elements. Permutations are also called arrangements. Okay, and let's explain this in Chinese again. 好，下面我们来看一下排列和排列数啊。什么叫排列呢？从 n 个不同的元素当中任取 r 个元素排成一列。当然，这个 r 肯定是小于等于 n 的，对吧？最多取到 n。考虑元素的先后出现次序啊，称此为一个排列。不同种排列的总数称为排列数，即为 Pnr。这个是比较常用的啊。然后有些书上也用 Pnr 这种形式，或者是 Pnr 写成一个函数的形式。若 r 等于 n，则称为全排列。好，这里指的排列啊，特指不放回抽样的排列。也就是说什么？假如说我有一个框，里边有 n 个不同的东西，取出来 r 个，按顺序排成一列。注意啊，按顺序排成一列。有多少种不同的排列方式？这个排列方式就称为排列数，我们记为 Pnr。Okay, so the question is, what is Pnr? What is this number? Exactly. So let's draw a diagram. Suppose we have n different elements in a container. According to the definition of permutations, permutations of drawing r elements from the n different elements and line them up. This number is denoted as Pnr, right? So what is Pnr here? So how many ways can you finish this task? Any ideas? So we can consider it as this. How many steps? Are there any steps to finish this task? Of course there are, right? Because when you draw R elements, you can consider it as R steps. So how many number of ways can you finish the first step? For the first step is to choose one element out of the n, right? So for the first step, you have n different ways to complete. So how about the second step? Second step is to choose one element from the remaining n minus 1 elements, right? Because once you have chosen one element out of the container, there are n minus 1 elements left in the container. So in the second step, you only have n minus 1 different choices, right? So how about the third step? The third step is to choose one out of the n minus 2 different elements, right? So remember there are r steps, right? So how about the r step? How many different choices for the r step? Okay, remember that for the first step you have n choices. Second step you have n minus 1 choices. Third step you have n minus 2 choices. Following the same logic, of course, for the r step we have n minus r minus 1, this number of choices, right? So according to the rule of product, this is the total number of ways you can complete this task. And we also know that this is actually denoted as PNR. So PNR equals the product of these numbers, right? Any questions here? Okay, so is there any way we can simplify this? Note that this is actually a product from n to n minus r minus 1. So we can denote it as a quotient between two different factorials, right? The factorials in the numerator should be n minus. And the factorial in the denominator is n minus r factorials, right? Can you see why we can rewrite this as a quotient of two factorials? Because note that n factorial is n times n minus 1 times n minus 2 times n minus r n minus r minus 1 and n minus r minus 2 dot 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 times 3, 2, 1, right? And n minus r factorial is n minus r times n minus r minus 1 times n minus r minus 2 dot 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 to 3 by 2 by 1, right? So if we use a quotient between these two numbers, of course we can cancel some items, right? You can cancel 1, 2, 3 until n minus r minus 1. So canceled with these numbers. So what's left there is a product from n minus 1, n minus 2 to n minus r. Any questions?
No.
Okay, so let's make summary. The following permutations formula. The following formula is used to find the number of permutations or arrangements of selecting R items out of N items. Note that here the N items should all be different. That is PNR equals N factorial over N minus R as a whole factorial. And this is a formula for sampling without replacement. That means if we draw an element, we do not put it back, or we do not replace any element to the original container. Okay? Okay, I'll explain this in Chinese again. OK，不放回抽样的排列数计算公式说的是什么意思呢？说的是这么一个模型啊，我们如果有一个容器，里边有 n 个不同的元素，然后你抽出来 r 个， ，R 个元素按顺序排成一列，每抽一个我们不往回放，也不往里补充，这样会越抽越少，对不对？最多抽到多少？最多抽到 n， 对吧？最少抽到0吧。好，对于这样一个模型来说，一共有多少种不同的抽法呢？一共有一共有 PNR 这么多种抽法。PNR 等于什么呢？刚才我们已经推导过了，等于 n 的阶乘除以 n 减 r 的阶乘，明白吗？这就是我们学的第一个数数的模型。好，大家把这个记一下啊，在笔记本上记一下。然后接下来我们看几个具体的例子。Okay, have I put this down? Let's see some examples. First example, club has 20 members. They are to select 3 office holders, president, secretary, and treasurer for the next year. They always select these office holders by drawing 3 names randomly from the names of all members. The first person selected becomes the president, and the second is the secretary, and the third one takes over as treasurer. Thus, the order in which the 3 names are selected from the 20 names is important. Find the total arrangements of 3 names from these 20. Okay, do you understand these questions now? Okay, let's see how we can do this. So there are 3 places, right? The task is to choose 3 different names out of the 20 different names and line them up in an order, right? Order does matter here because the 3 positions are not the same. So according to the definitions of permutation, this is actually a permutation, right? A permutation without replacement. So we can directly solve it using the formula of permutations. So this is PNR. N is 20, right? R is the number of elements you draw from the container. So P23, this is a solution for this question. P23, remember that the formula is PNR is n factorial over n minus r factorial, right? So that means 20 over 17 factorial, which is 20 by 18 by 20 by 19 by 18, right? Okay, so this is method 1. Okay, so how about the second method? You can also solve it in the second method. Remember that when we discuss the permutations, the permutation formula is actually derived from rule of product, right? So in the second method, we can use rule of product. So normally, if you can use permutations without replacement, you can also use rule of product. So how do we use this? To finish the whole task, the task consists of 3 steps, right? 3 steps. The first step is to choose a name and let this person be the president, right? So how many ways can you do this? We can choose 1 name out of the 20. So that means for the first step, you have 20 different ways to finish. How about the second step? Once the person has been chosen as a president, there are 19 names left, right? So the second step is to choose 1 out of the 19. So we have 19 different ways to finish the second step. How about the third step? Okay, if the president and secretary have been confirmed, next we only have 18 names left in the container, right? The task in the third step is to choose one from the 18. So there are 18 different ways to complete the third step. So to finish the whole task, there are 20 by 19 by 18 different number of ways, right? This is the same with the result we have obtained in method 1. Okay, any questions? No? Okay, the correct result is 6840. Okay. All right. If you have no questions, let's see another example. How many different batting orders are possible for a baseball team consisting of 9 players? Okay, what does this mean? This means you have 9 players, right? And we want to arrange their orders. How many orders can you arrange them? Okay, this is equivalent to there are 9 different elements, and we pick 9 elements out of the container and line them up. How many ways we can do this? So this is also a permutation problem, right? The solution is to pick 9 out of 9, so P99. So this is a full permutation, right? And P99 is 9 factorial, according to the permutations formula, right? Any questions? No? Okay, let's see the next one. Okay, next question. I'll leave this for you to complete by yourself, okay? I'll give you 5 minutes. Miss Jones has 10 books that she's going to put on her bookshelf. Of these, 4 are mathematics books, 3 are chemistry books, 2 are history books, and 1 is a language book. Miss Jones wants to arrange her books so that all books dealing with the same subject are together on the shelf. How many different arrangements are possible? Okay, you can either use rule of product or use permutations, okay? All right, you can start. Okay, any ideas? So to finish this task, are there any steps? Of course there are, right? So how many steps are there? There are 5 steps, right? First step is to arrange different subjects, right? So this is to decide which subject is in front and which subject is at back. So second step is to arrange, how about mathematics book? And third step is to arrange chemistry books and etc. Right? So following this logic, we can use rule of product, right? For the first step, so how many different ways we can arrange different subjects? We have mathematics, chemistry, history, or language. So there are 4 different subjects, right? The task is to pick 4 different subjects, or to pick 4 subjects out of 4 different subjects. So for the first step, there are P4 different ways to finish, right? So how about the second step? Second step is to arrange different mathematics books. That means we pick 4 books out of the 4 mathematics books. Third, following same principle, we pick 3 out of 3 chemistry books. Next, we pick 2 out of 2 history books. And last, we pick 1 out of 1 language books. All of these numbers are full permutations, right? So for full permutations, Pnn, this equals n factorial. Can you see why? Because Pnn, according to the formula, is n factorial divided by n minus n factorial. N minus n factorial is 0 factorial. 0 factorial is 1. So Pnn is always n factorial, right? So this means P44 is 4 factorial times 4 factorial times 3 factorial times 2 factorial times 1 factorial. So this is our final result. So you really will need to calculate this number. This number is 6912. Okay, have a look at this. Any questions?
Oh,
All right, let's see the next piece of knowledge. In today's lesson, we're gonna discuss permutations sampling with replacement. So when a population element can be selected only one time, we're using sampling without replacement. When a population element can be selected more than one time, we are sampling with replacement. So what does this mean? In sampling without replacement, that means if we have a container that contains n different elements and we draw r different elements, for each draw, we do not replace the original container, or we do not put the element back into the container for the next draw. Okay, so in the sampling with replacement, that means if we have a container that contains n different elements, and also we need to pick our elements out. For each pick, when we pick the element out, we put it back for the second draw. Or you can treat it as for each pick, when we finish the pick, we add the same elements back into the original container. So that means the container always contains n different elements, right? So this case is called sampling with replacement. So now can you imagine what is the number of arrangements if we draw our elements from n distinct elements sampling with replacement? So how many different ways can we do this? We can use rule of product, right? So if we draw our elements out of n elements with replacement. That means to finish this task, there are steps, right? For the first step, how many ways we can finish the first step? First step is to draw one element out of the n elements in the container, right? So for the first draw, we have n different ways to finish. How about the second draw? Remember that when we finish the first draw, we replace the original container with the same elements we draw, right? So that means the container always contains n elements. So for the second pick, we also have n different choices, right? So times n for the second step. So how about the third step? Third step, we also have n different choices. And this is for all the steps until for the last step. For the last step, again, we have n different choices, right? So how many n's here? Because we have r steps, so there must be r n's, right? So this equals n raised to the r's power, right? Okay, so let's make summary. Okay, I'll summarize it in Chinese again. 从 n 个不同元素中每次取出一个，放回后再取下一个，如此连续取 r 次，所得到的排列称为重复排列。此种重复排列的数共有多少个呀？共有 r 的 n 次那个，对不对？因为什么呢？因为刚才我们画了一个图，是吧？假如说容器里有 n 个不同的东西，你取出来 r 个，每取一个，往里面放回一个同样的东西，也就是说这个容器里始终都有 n 个，始终都有 n 个不同的东西啊。然后每取出来一个。取出来，然后把它们按顺序排成一列。刚才我们分析了，最后的结果应该是 n 的 r 次幂这么多个，是不是 ？Any questions? Okay, if you don't have any questions, let's look at an example. Okay, suppose we have a combination lock. So how many different combinations are there for this lock? Okay, I'll give you 1 minute to think about this. Okay, any ideas? So an intuitive way to think about this, of course, the combinations come from 000 to 999. There should be 1,000 different combinations, right? So this is a first solution. Also, if we consider this in permutations, this is a model of choosing 3 digits out of 10 different digits, which range from 0 to 9, right? And line them up in some order. So we have 3 positions here. And for each pick, after the pick, we automatically replace the original container using the same digit you pick, right? So that means in this container, there are always 10 different digits for you to pick. So this is permutations with replacement. And also we know the model has a solution of nr. So n is 10, r is 3, and the total number of different combinations should be 10 raised to the third power, right? Okay, anything you want to ask? No questions?
No.
Okay, so this is all the knowledge we have learned for today. And next, the remaining time is for you to complete today's homework, okay?